Hello everyone. In this video, we're going to solve this interesting limit problem that involves geometry. Here, we're given a sector of a circle with central angle theta, and we want to find the limit of the ratio of this blue region here and this red region as theta approaches zero from the right. That is, as this angle here gets smaller and smaller, or as this line segment here gets closer and closer to this horizontal segment. Let us denote the center of the circle as O and this point here as P, and then this point as Q, and this point here as S. And suppose that we have a circle of radius R. So that is the length of this OP is equal to R. So we can find the area of this blue region here by finding the area of this sector minus the area of this triangle. So B is equal to area of the sector minus this triangle OPQ. Now, because this sector here has radius R, then the area of this sector is equal to 1/2 R squared times theta. Note that theta here is in radian measure. And because this segment here also has a length which is equal to R, then the area of this triangle OPQ is equal to 1/2 times R times sine of the included angle, which is equal to theta. Therefore, the area of this triangle OPQ is equal to 1/2 R squared times sine theta. Therefore, we can write the area of the blue region as a function of theta, and that is equal to 1/2 R squared times the quantity theta minus sine theta. Now let's find the area of the red region in terms of the angle theta. The area of this red region is equal to 1/2 times base, which is equal to SQ, times the altitude or height, which is equal to SP. And the length of SQ can be written as R minus OS, because the length of this is R, and then minus this OS here. So we'll get the length of SQ. Now, because this is a right triangle, we can find the value of the length of this side here and this opposite side using SOHCAHTOA. And here we'll be able to get OS is equal to R cosine theta. So it is like from SOHCAHTOA, cosine of theta is equal to adjacent, which is the length of OS, over hypotenuse, which is equal to R. So therefore, the length of OS is equal to R cosine theta. And also for SP, so when we take the sine of theta, we'll get the opposite side, which is the length of SP over the hypotenuse R. And that will give us R sine theta. So we can also write the area of the red region as a function of theta as 1/2 R squared times the quantity 1 minus cosine theta times sine theta. Let us now compute for the limit of the ratios of these two areas. Note again that our B of theta is equal to this one and R of theta is equal to this expression. Therefore, the limit of B over R as theta approaches 0 from the right is equal to the limit of this quotient. And here we can cancel this common factor here. And if we look at the limit as theta approaches 0, then the limit of the numerator is equal to 0 minus sine of 0, which is 0, so that is 0, over sine of 0 is 0, so over 0, which is an indeterminate form. So here we're going to apply L'Hopital's rule, but before that, let me simplify our expression to theta minus sine theta and the denominator as sine theta minus 1/2 sine of 2 theta. So we can write sine theta cosine theta as 1/2 of sine 2 theta from the identity sine 2 theta equal to 2 sine theta cosine theta. And why are we doing this? Because it's easier to compute for derivative if this product is written as 1/2 sine 2 theta. So now applying L'Hopital's rule, we'll get here limit as theta approaches 0 from the right of the derivative of this. which is 1 minus cosine theta, and the derivative of sine theta is cosine theta, and the derivative of this one is equal to 1/2 times cosine 2 theta times 2, which is equal to cosine 2 theta. And if we look at the limits of the numerator and denominator, the numerator will again approach 0. So that is 1 minus cosine of 0, which is 1. So 1 minus 1 is 0. Over cosine of 0 is 1. So that is 1 minus, again, cosine of 0. So 1 minus 1 is 0. So again, it is an indeterminate form. And applying L'Hopital's rule again, we'll get here limit as theta approaches 0 from the right of sine theta over negative sine theta. And the derivative of this is equal to negative sine 2 theta and then times 2. So we'll get the negative of this one, which is equal to plus 2 sine 2 theta. Now, what are the limits of the numerator and denominator? So the limit of the numerator is 0. Limit of the denominator is again equal to 0. Again, an indeterminate form. So let's try to perform L'Hopital's rule again, and we'll get here limit as theta approaches 0 from the right of cosine theta over negative cosine theta. And again, the derivative of sine 2 theta is 2 cosine 2 theta. So that will give us 4 cosine 2 theta. Now, as theta approaches 0 from the right, this goes to cosine of 0, which is equal to 1. Again, this will approach 1. This will approach cosine 0, which is equal to 1. Therefore, we can already apply our quotient rule, and we'll get the limit, which is equal to 1 over negative 1 plus 4, which is equal to 1/3. Therefore, when this angle here is close to 0, the area of this blue region is 1/3 of the area of this red region. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to help me grow this channel. Thanks for watching, and I hope to see you next time. Bye-bye.